Okay, so this is the second video about the crossover rule. Hopefully you've watched the first one, made notes, and had a practice. So you'll already be very familiar with the fact that metals tend to lose electrons because it's energetically favourable for them to do so, to form positive cations. And if you're in group 1, you will form a +1 cation, group 2, +2, etc., etc. Non-metals are the opposite. They have a tendency to gain electrons, being energetically favourable to do so, and they form negative anions. If you were in group 7, you'd form a -1 ion, group 6, -2, etc. Remember that group 8 already have a complete outer shell. It is not energetically favourable for them to gain or lose electrons, so they don't participate in bonding very much. And group 4, being in the middle, is a little bit of a grey area which we don't really deal with at GCSE. So what are we going to do in this video? We are going to look in this video at using things called compound ions. Okay, what are the compound ions? Well, there are 5 compound ions. 1, 2, 3, 4, 5, which really I guess I should put down as 1, 2, 3, 4, and 5, because there are 4 anionic compound ions and 1 cationic compound ion. These you need to learn. There's no two ways about it. You need to learn them. So we're going to look to see how we can, once we've learned them, how we can use them. So let's just jump straight in and do some examples. Let's start with lithium sulfate versus lithium sulfide. And you'll notice that there is a difference here, the difference being the 8 at the end of the first compound and the "ide" at the end of the second. Let's deal with the second one first, because it's something we've pretty much already dealt with. Lithium, Li. Sulfur, it ends in sulfide, so it means it's derived just from sulfur itself. So that's just going to be S. If it ends in "ide", apart from hydroxide, which we'll come to in a bit, if it ends in "ide", it's just derived from the element itself, so it's just the symbol with the requisite charge. So lithium is going to be +1, sulfide is going to be -2. Line underneath, take the size of the charges down, cross them over. This is going to be Li2S, lithium sulfide. Lithium sulfate, however, 8 generally is, you can think of it as there's oxygen involved as well, which means we've got a compound ion. Sulfate, as you can see over here, is SO4 2-. So this time we have to put in the entirety of the compound ion. Lithium is still going to be Li, sulfate SO4. Now we're going to put our charges in, +1, -2. Now, if you remember, I said in the last video, you really have to put a line underneath. Why? Well, if I don't put my line underneath and I cross over, I might make a mistake and cross the 4 over, but the 4 is not the charge, the 4 is part of the compound ion, so that would be a mistake and that would be wrong. So let's get rid of that. Let's draw my line underneath, bring my charges down, the size of my charges, 1 and 2, cross them over, 2 and 1. That means I've got 2 lots of the lithium, Li2, and 1 lot of all of this thing, sulfate, 1 lot of all of SO4. And because I've only got 1 lot of it, I can just write that in. But what if I have more than 1 lot of it? Well, let's look at a different example. Let's look at magnesium nitrate as an example. Okay, magnesium, Mg, nitrate, NO3, and with our charges in, NO3 -1. I've written up as 1- up there, up here, and -1 down here. Doesn't matter which way around you write it, to be honest, it's absolutely fine. Magnesium is in group 2, so will be +2. Take down the size of the charges, 2. What number do I write under the NO3 minus 1? Hopefully you said a 1 because it's the size of the charge, nothing to do with the 3. The 3 comes in later. Cross those over, 1 and 2, which means I have 1 of the magnesium and 2 of all of that nitrate. So how do I show I have 2 of all of that nitrate? Well, Mg with the 1, that's fine. NO3, 2. No, that means I've got 32 oxygens and just 1 nitrogen, so that's not going to be right. How about NO6? That's timesing the 3 by 2. That kind of makes sense. Well, that means I've got 6 lots of oxygens, which is 2 lots of 3. That works. And I've got just 1 nitrogen. Well, that's not 2 lots of 1, so that doesn't work either. So I need to have my NO3, and I put brackets around it, and I put the 2 outside, which means I'm multiplying everything inside the bracket, which means I've got 2 lots of all of NO3. Which, if you just do a quick count, means I've got 1 magnesium, 2 nitrogens, and 6 oxygens. So that is the use of brackets. Let's do maybe 1 or 2 more of those just to make sure we've got the idea. Let's try aluminium sulfate. It's the sulfate. It's the one with oxygen. Okay, might be a good idea if you want to pause it and have a go at this for yourself. Pause the video, that is. Have a go at this for yourself and see if you can do this on your own. If you're not confident, watch this one through and then maybe do the next one. So aluminium, where's aluminium? It's up there. So Al plus 3, sulfate SO4 minus 2. How do I know it's SO4 minus 2? Sorry kids, I've just had to learn it. It is there and I've just had to learn it. So all of these ones in this box, you have to learn whether you're going to do that with a Quizlet or flip cards or just writing out lines, however you're going to do it, you've got to learn it. Okay, so back down to the bottom. What have we got? Al3 plus, so let's take the magnitude down at 3. SO4, 2 minus, what do I take down? The 2, the size of the charge. Let's cross them over, 2, 3. I've got 2 lots of the aluminium, but aluminium is just a simple ion, so I don't need to use brackets or anything. Al2. I've got 3 lots of the sulfate. Sulfate is a compound ion, so if I've got multiples of it, I do need the brackets. SO4, close brackets, 3. Al2, SO4, 3, which means I've got 2 Als, 3 sulfurs, and 3 times 4, which if my maths is holding up today, is going to be 12 oxygens. Right, let's do one more. Let's do a hydroxide. So let's do calcium hydroxide. Why am I choosing this? Calcium hydroxide is quite important actually as a compound at GCSE. Calcium hydroxide, if we dissolve it up in water, it doesn't dissolve very well, but if we do dissolve it up, it is lime water, so it's probably something you ought to know. Calcium, Ca plus 2, hydroxide, OH minus 1, line underneath, take down the size of the charge, 2, 1, cross them over, 1, 2, 1 lot of Ca, 2 lots of all of OH. If I just write OH2, that can't be right because I've got 2 H's but only 1 O. It's a compound ion. How do I show that I have 2 lots of all of the compound ion? I use my brackets. So there we go. Ca, open brackets, OH, close brackets, 2. Okay, so that's the compound ions. We have to learn the compound ions, and if we have more than one of a compound ion, we have to use brackets. And we have to be very careful when reading the names. Does it end in ate or in ide? Sulfate, nitrate, carbonate, they're all ending in ate. They all have oxygen involved. Hydroxide, hopefully it's obvious. Hyd from the hydrogen, oxide from oxygen. Hopefully it's obvious it's got hydrogen and oxygen involved. And ammonium, which we haven't dealt with, but I'm sure you can do a crossover rule with it now. You just have to learn that. So, one last thing we said we're going to do on this video. crossover rule with transition metals. So let's just have a quick remember here. What are transition metals? Well, they are these dudes in this block in the middle, these guys here. Now the trouble with doing transition metals is they're not in a group, so they don't have an obvious charge. Well, actually, do you know what? That makes life easier because they have to tell you what the charge is. So for example, there isn't really no compound called iron oxide, but there is a compound called iron 2 oxide, and there is a compound called iron 3 oxide. What are those 2s and 3s, those Roman numerals, telling you? They are telling you the charge. They are telling you the charge on the iron. I didn't pick a very good one there. It's always confusing when you're talking about iron ions, but let's go with it. So this is going to be Fe. What's the charge going to be? Well, it's been told. It's 2. And it's a metal, so it's got to be positive. So it's got to be plus 2. Oxide, O minus 2. Line underneath, 2, 2. Cross them over, 2, 2. And hopefully you remember from the last video, we always give the simplest ratio. So that's 1 to 1. So this is going to be FeO. That is iron 2 oxide. Iron 3 oxide. So it's going to be Fe. What's the charge? Well, it tells us 3. Plus or minus? Well, it's a metal, so it's got to be plus. Fe3 plus O minus 2. 3, 2, just the sizes of the charges, remember, cross them over. 2, 3. Fe2O3. There are more examples of these. You are pretty much always told. So, for example, copper 2 is going to be a copper 2 plus ion. Titanium 4 is going to be a titanium 4 plus ion, etc., etc. Let's just write a couple of these in as examples. Copper 2 would mean you would use Cu2 plus in your crossover rule. Titanium 4 IV, let's get that the right way around, would be Ti4 plus. Remember, these are always plus because they're always metals. Okay. There are, however, 2 to learn. Zinc is always Zn2 plus, and silver is always Ag plus as far as you're concerned at GCSE. So those 2, zinc and silver, these are ones that you have to learn. So again, you can chuck those in with the flip cards or the Quizlet you are going to make for learning the compound ions. Other than these 2, you will always be told the charge on your transition metal ion using Roman numerals. As we've done before, let's just find a different colour highlighter. Iron 2 gives us a 2 plus. Iron 3 gives us a plus 3. Copper 2 gives us a plus 2. Copper 1 would give us a plus 1. Titanium 4 gives us a plus 4 or 4 plus. Titanium 3 would be plus 3. Titanium 2 also exists. That would be plus 2. As with all of these, practice, practice, practice. Make notes. Have a go yourself. Get the learning done. Then practice so your understanding improves. Other than that, remember to use your brackets where necessary, and remember to read very carefully the ends of the words. 8 means there's oxygen involved. It's a compound ion. Ide, unless it's hydroxide, means it's just derived from the element itself. Hopefully that is helpful.